Hi, everybody. It's September 9th, 2020. We are continuing our weather unit, Unit 2, Weather Interactions. Quick announcements for today. Make sure that you're getting your missing work, your redos, late submissions, all that stuff in. That's going to lock out tonight at 11:59 p.m. Everything is going away. No more doing stuff from Unit 1. It's been about 4 weeks, so we should be all caught up by now. So anything that you still need to redo or anything like that needs to be done by 11:59 p.m. I did not add extra redo, so everything has at least 2 attempts already attached to it. So if you're taking your 2 attempts, that's over with. But if you didn't take your 2 attempts or you didn't turn something in, you got till tonight, 11:59 p.m., and then I gotta cut you off because I have to get the grading done in order to get your progress report stuff done. Unit 1 retest will also post today and be available until Friday. And I'm reiterating that you use email to communicate with me. Please use the email address. Today's learning target. We are continuing to recognize that the sun provides the energy that drives convection within the atmosphere and oceans, producing winds. So we know that the sun is going to provide that thermal energy that drives convection, and that convection is going to be the main factor in producing wind and our weather systems. So for our learning task today, you have this lesson video. So you're just going to stay here. You don't have to click out. It's going to be attached to this intro video. And you're going to do an unequal heating of Earth quiz. You also have those notes from yesterday. So if you set your notebook up yesterday, then you're good to go. You're just going to stay right here and continue listening and getting the information you need for your notes. If you did not set up yesterday, or you're going to do, then you might want to pause to go back and set up, or you're going to do the complete sentences like I explained yesterday, where you don't have to write the question as long as you write out, you flip the question and write a complete sentence so you actually know what the question was asking from your answer. Don't forget to click that attendance link and enter that P for present. This is especially important for my virtual learners. Need everybody to do it, but especially the virtual people. So we can make sure your attendance is straight. So your notebook on page 12 and 13 should look like this. This is also located in the Schoology folder, so you can go there and click on it and get a bigger version that you can see a little better. I don't know. I'm trying to think of what this will look like to you guys because my view is different. But there are 12 questions. Remember, you have the option, write the question or flip the question so that you just have a page of notes, okay?
Ah! Dear Tim and Moby, where does wind come from? From hope. Well, that's one way to move air, and that's just what wind is, moving air. But there's no giant propeller pushing wind around the Earth. Believe it or not, the wind is caused by the sun. If you've seen our thing on seasons, you know that the tilt of the Earth causes some places to be hot or cold at different times of the year, and other places to be either hot or cold all year round. The uneven heating of the Earth's atmosphere is what gets air moving. The sun heats up the Earth's surface, warming the nearby atmosphere. Warm air is less dense than cool air, so it rises. That leaves some empty space, and cool air from nearby rushes in to fill it. The area of rising air is what weather reports call a low-pressure system. As the warm air rises, it cools off and eventually sinks back down. The system is like a big engine sucking in air from all around it. What you end up with is a whole lot of moving air, and that's what we here at BrainPop like to call wind. There are different types of wind that blow in different patterns. Prevailing winds blow all the time over a particular part of the world. They're constant because the equator always gets more direct sunlight than the poles, Warmer air at the equator creates a huge low-pressure area, which is filled by cooler air from the poles. Their direction is affected by the Earth's rotation. Winds in the northern hemisphere are deflected to the right, and they turn to the left in the southern hemisphere. Jet streams are strong winds that blow about 10 kilometers above ground. They blow in circles with one jet stream over each hemisphere, and they blow fast, up to 200 kilometers per hour. Jet streams can move big chunks of air and really affect weather. Trade winds are mild, constant winds that blow towards the equator from the northeast or southeast. Where the trade winds meet, there's a calm area called the doldrums, where there's hardly any wind at all. Local winds are particular to certain countries or areas. Geographic features like mountain ranges or bodies of water can drastically affect wind conditions and create localized winds like the Santa Ana winds in the North American Rockies and the Föhn in the European Alps. Wind power can be harnessed to make electricity, which you can learn about in our Energy Sources movie. What are you doing? What do you mean you're trying to break wind? You can't break wind. It's made of air. What?
So, unequal heating of the Earth. The source of almost all Earth's heat energy is the sun. The sun gives off its heat in the form of electromagnetic radiation, which travels through space. About 45% of the sun's radiation is actually absorbed by the oceans and lands. The remaining 55% is sent back into space. The sun's heat is distributed throughout the atmosphere, land, and the oceans by radiation, conduction, and convection, providing energy to make weather. Thermal energy always moves from substances of higher temperature to substances of lower temperature. The heat is going to be lost. So if it's hotter, it's going to lose heat energy to the cooler object or the cooler matter. Unequal heating of Earth occurs mainly due to Earth's tilt on its axis. Because the Earth is a sphere, areas closer to the poles receive indirect rays at a much more shallow or oblique angle and have cooler temperatures. The sun's rays are more direct and straight on at the equator, resulting in warmer temperatures. This causes the global air temperatures to vary greatly. This is also why the equator is always warm and the poles are always cold. This uneven heating creates convection currents in our ocean and atmospheres, and this movement has an impact on our weather too. Hopefully you recall that when water is heated, it expands and its density decreases. Less dense matter tends to rise in a fluid such as ocean water. As the area around the equator warms, convection occurs in the oceans distributing the heat. Moving water in the oceans are called ocean currents. There are two types of ocean currents, surface currents and deep currents. Global winds blowing across the ocean transfer energy to the ocean. The winds drag along the surface of the ocean, creating currents that move along the surface of the ocean. Surface currents are classified into two groups, cold currents and warm currents. Cold currents tend to move from Earth's polar regions toward the equator. Warm currents move from the tropical latitudes toward the poles. Ocean surface currents are caused mainly by global winds. The ocean surface currents move in a curved pattern because of the Earth's rotation. Other factors, including the temperature of the ocean, influence the complex spirals of ocean currents. Deep ocean currents happen because of differences in density, which result from temperature and salinity differences. Salinity means the amount of salt dissolved in the water. Cold water is denser than warm water, and water with many dissolved salts is denser than water with fewer dissolved salts. When colder, saltier, denser water meets less dense water, the denser water dives under the less dense water.
That was a lot of leaves.
Yeah,
Let's go eat.
good idea. Oh, whoa!
That huge gust came out of nowhere.
How come wind is so powerful? You can't even see it.
Bad breath is invisible too, but it's pretty powerful.
Oh, gross.
Our breath and the wind are made up of the same thing, air molecules invisibly floating in space. That's what gives wind its mass or substance.
And when it's windy, all those molecules are moving?
Like a herd. Sometimes they float gently in a breeze, and other times, like in a hurricane, they're blasted along at hundreds of miles an hour.
But what makes the wind strong or weak?
Everything from a breeze to a hurricane blast is caused by air pressure. That's the force with which air molecules push against us and everything around us. When the air pressure changes, so does the strength of the wind.
What makes air pressure change?
The height above sea level, the temperature, and the amount of water vapor in the air. Those three things make air more or less dense. When air gets colder and closer to sea level, it gets denser. That means the air molecules are closer together, so there's more air pressure.
So when air gets warmer and higher, there's less air pressure?
Right. The air molecules are farther apart, or less dense.
Hey, it's like the leaves we picked up. When they're together, they're heavy and hard to lift. But scattered around, they're lighter.
Yeah. So it makes sense that dense air sinks and less dense air rises. The pattern of rising and falling air is called a convection cell.
Convection cell?
Check it out. Say we're at the beach. In a convection cell, the air over the sea cools and sinks. That's a downdraft. At the same time, the air over the land gets warmer and rises. That's an updraft. The cool, high-pressure air moves towards the land and heats up, replacing the warm air. And the warm, low-pressure air moves out to sea and cools, replacing the cool air. The movements of the air cause wind. All this air movement is affected by one more thing.
Lay it on me.
The Earth's rotation. As the Earth spins, it pulls the wind and makes it travel on a slightly curved path, from west to east, or east to west. It's called the Coriolis effect. Anyways, there are all kind of winds. They even have names.
Yeah, like a breeze and a gust and...
Well, no. Like polar easterlies, prevailing westerlies, and trade winds.
Huh?
Polar easterlies are winds that come in from the poles and blow east to west. Prevailing westerlies are warmer winds blowing in the middle latitudes, and trade winds are near the equator.
So that gust of wind that blew through and ruined our hard work, was that a prevailing westerly since we live in the middle latitudes?
It probably was.
You know, this wind thing is pretty fierce. I never realized wind was caused by changes in air pressure, or that air pressure is affected by three things: temperature, height above sea level, and amount of water vapor in the air. And the convection cell stuff? Hot air rising, cool air sinking? It's wild. But it's not as wild as the Coriolis effect. That's the spinning of the Earth that makes winds curve. Wind is invisible, but so powerful.
Wow, Sam, I'm blown away.
Well, it was quite a whirlwind of information.
After you completed your notes, you will take the Unequal Heating of Earth quiz on Schoology. This will be available to you until Friday at 11:59 p.m. Then the quiz will lock out. So you can complete it today, or if you're not ready, you have until Friday to get it done.